today we will be solving absolute value inequalities. So let's take a look at our first problem here. Notice I have the absolute value of x is less than 5. So let's think just about what those numbers would end up being. The numbers that we could put in place of x to get 5, ignoring our inequality sign now, would be either 5 or negative 5. Those values both would give us values of 5, at least the endpoint. Now let's take a look at our inequality. So we know the values of x are either going to be negative 5 or positive 5. Now there are values in between because we have an inequality sign, or they are to the outside, depending on what the inequality sign is. In this case, if you think about it, the values of x have to be less than 5. So numbers that would be less than 5 that would get us values would be like negative 4 or positive 4 or 0. See, those are values that when we take their absolute value, we get something that is less than 5. So that tells us that we are dealing with an AND statement. And so if I was to set this up, I would say that the values of x are less than 5, but they are greater than negative 5. And so if I was to graph this, negative 5 is on this side, positive 5 is on this side. The values of x are greater than the negative, but they are less than the positive, and so those would be our solutions. Now notice it's a little bit different for this one. Notice the x values need to be greater than 5, so let's just pick some numbers that would be greater than 5. We know the end points are going to be negative 5 and positive 5, but if you look at this, the values of x need to be something like 6. See, the absolute value of 6 equals 6. That is bigger than 5. Or we could end up with a number that's smaller, like negative 8. See, if I took negative 8, that would give me 5, or 8. That is bigger than 5. So notice that the values this time, instead of going in between, they're not numbers in between. They're numbers on the outside. See, 6, negative 8, those are numbers that are either less than negative 5 or greater than 5. So that means we have an OR statement here. So if I was to set this up, knowing that it's greater than, and the way you can remember greater, greater, see if you look at that word, if you think of greater as, instead of greater this way, think of it as greater, and it has that word or in it there. And so whenever you see an absolute value that's greater than a number, as long as the absolute value is by itself, there's no number like a negative sign outside. If there were a negative sign here, we divide by the negative, it'll end up switching the inequality sign, which would switch it to an AND statement in that case. So if it's greater, it's an OR statement. Less means an AND statement. So less is in between, greater is to the outside. So let's go ahead and set it up. We know that's a greater here, so x is going to be greater than the 5, or it's going to end up being x is less than the negative 5. And so we can go ahead and graph that. We know that, again, the values are in between, and the values that are x are less than the negative 5, but greater than the positive. Another way to set these up is on this one here, is you see how when we went ahead and wrote the inequalities for this one, notice how they're kind of pointing the same direction. They don't mean the same thing when we read from the x. Here, it's x is greater than negative 5, x is less than 5. But notice how they're pointing the same direction. Well, you could get away with doing that with this one. So you could have them point the same direction. As long as you put the negative sign on the left, positive on the right, x in between, you could point them this way. Now, you can't write the answer this way, though. You cannot write the answer this way. This way would not get you the right answer. You have to write, we'll say, must write as, and then we would say x is less than negative 5 or x is greater than positive 5. So you've got to write it that way with the word or in between, not this way. But if you do write it this way, then you would see, if you read it off, that it does match this inequality here. So let's go ahead and try some problems that you'll see on tonight's homework. Again, when you want to solve an absolute value problem, equation, or inequality, you always isolate the absolute value. So that's what we're doing here. Absolute value of x is less than or equal to 1. So that means that it's an AND statement. It's less than. So if I set it up, x is less than or equal to 1, and x is less or greater than or equal to negative 1. So it's always going to be greater than the negatives, less than the positives. So here's -1, here's +1. We can go ahead and draw some solid circles there. And again, the values of x are greater than -1, less than positive. Now at the greater, you remember that it's an or statement, but if you don't, again, isolate the absolute value. You can always do this. You can always just set it up whichever way they're pointing. Let's go ahead and erase the graph portion, but if I have it set up like this, see they're pointing both towards the right, kind of ignoring the x value here for now, then you'll get your answer. But you can't write the answer this way. You see, x is less than -8, or x is greater than +8. So that's the way you got to write it. And when you go ahead and graph it, you'll see that it matches that. So greater than the positive, less than the negative. So those are the solutions there. So box these. So let's take a look at our next one here, a little bit tougher. Here we've got more involved inside the absolute value bar. So let's go ahead and set it up this way. X plus 4 is less than or equal to 2, but greater than or equal to -2. So we go ahead and solve. And so when we do that, we subtract the 4 from all sides. And when I do that, I see that we have two negatives there, so I'm adding those numbers. -6 is less than or equal to x, which is less than or equal to -2. So this is our solved inequality. And so when we graph it, notice that the smaller numbers, the smallest end point here, the values of x are greater than it. See, x is greater than or equal to -6. Here, the x values are less than or equal to the -2. So all the values are in between. That would be our solution. Next problem. We have to set it up again the same sort of way. 3x minus 4 is greater than 2. And again, if you want to set it up as an or statement right now, it'd be easier. Or you could just go ahead and have those inequality signs kind of pointing the same direction. And then solve it that way. The only thing is, doing it this way, you have to rewrite it at the end as an or statement. So here I'm going to add 4 to all sides. So now I'm left with a 2 is greater than 3x, which is greater than 6. So I go ahead and solve a little bit further, and I'm dividing by 3, and I've got myself a fraction on the left. That's okay, I can deal with that. And so that makes 2/3 is greater than x, which is greater than 2. Now you can't write the answer this way, because if you look at the graph, 2/3 is here, and I've got 2 over on this side. Notice that the inequality says that x is less than 2/3, but greater than the positive. So you've got to write the answer as an or statement. Less than 2/3, but or greater than +2. So those would be our answers there. Let's take a look at our next one. Again, you got to isolate the absolute value. So here I've got to subtract the 1 from all sides. So I'm left with 2x plus 1 inside the absolute value bars is less than 7. So when I solve this, I'm just going to set up my absolute value, and it isn't an and statement because it's less than the positive, greater than or equal to the negative. So we go ahead and solve by just doing opposite operations. So here I'm going to subtract the 1 from all sides. So that leaves me with a -8 is less than or equal to 2x, which is less than 6. So from that point, we can go ahead and divide by 2. So when I divide by 2, I end up with -4 is less than or equal to x, which is less than 3. So from this point, and actually it's not equal to, just less than, so let's go ahead and cross that out. There we go. So x values are greater than the negative, but less than the positive. So when I go ahead and graph this, starting at the -4, putting a circle on that, putting a circle on the 3, and all the values of x are greater than the negative, but less than the positive. So let's take a look at our next problem, the last one here. So we're going to subtract the 9 from all sides. Now, when I take 9 from 10.5, that leaves me with x minus 1/2. In the absolute value bars is greater than 1 1/2. Let's stick with that 1 1/2 for right now, because when we go ahead and work with it, we're going to be adding 1/2 to both sides, and that's going to eliminate that fraction. So notice how I have the inequality signs pointing the same direction. Set one to a negative, the other to a positive. So the values of x are going to be less than the negative, but greater than the positive. And so when we go ahead and solve, we've got to add 1/2 to 1 1/2, but then add 1/2 to negative 1 1/2. So here we end up with a negative 1. So x is less than the negative 1, but it's greater than 2. 1/2 and 1/2 makes 1, plus 1 makes 2. So you're not going to see the answer this way. You're going to want to write it as an or statement. X is less than negative 1, or x is greater than 2. So the values are right in between. Negative 1's here, positive 2's here. We got the open circles, and x is less than the negative, greater than the positive. And those are the solutions to the lesson problems. Good luck on tonight's homework.